Well, let's just put it this way. I'm going to talk about global warming. Simple. As far as their criteria, whatnot, it's nice, but as you notice, the winters get shorter. Winter this year stopped in January. Not much in February, March, April, May, or June. A little bit, but not much. As far as the distance from the reference of Earth to the Sun, you need a winter that starts in November minimally to end in May to keep the weight of the sun the Earth up. As far as taking and digging and drilling and oil and all that, you tend to forget that this is a fat. What's called I call it a fat in reference, a fat rotation. And what a fat rotation is you take a red bouncy ball and you split it right down the middle. And you stick 2 water balloons left and right side, and you stick another one on the other 2 opposite sides, so it would be north, south, east, west, laying flat in the center of a bouncy ball. You take the bouncy ball and you take a heat gun and you seal it back up. You take a pin that you normally would put air into the bouncy ball and you ream it out a little bit, put a metal bracket in, and then sit there and spin it. If you stick your finger on the top of this little bouncy ball, which now acts up, and you put it on not a gyroscope, but you put it on a mount that allows it to move around, but allows it to stay relatively flat, you'll notice that it'll wobble. And everyone's seen one of those balls I have. The rubber's been damaged and it's filled up with air pocket. It just wobbles all over the place. Now this ain't the case, but this is the case in the sense that that wobbly ball is really starting to deflate. And as it deflates and whatnot, you lose the weight to keep yourself away from what they refer in reference as gravity of the sun and whatnot. And as that spins around, it's not pushing itself on the outward towards Mars or these other planets. Now it's starting to gravity starting from the sun, starting to take over and pull the Earth into itself, or at least towards. Technically, the 1,000 year projection done in 1984, when I was 7 years old, actually 6 years old, fell. Let's just say I talked to a Harrison and a Harrison Ford, who claimed to be a climatologist. Whether or not he really was is another question. Europe got a direct write-up on what will happen in the next 1,000 years, not 1,000 generations. And what will happen is sooner or later you're going to see the mass roundness of the Earth smash into the sun unless you can defeat it and whatnot. So when we start talking about vehicles, start talking about not using petroleum, not using water, not using this or that, not messing yourselves up, then you might want to start listening, because if I were to fire a rocket today from anywhere in the world, starting at sunrise and having control of the rocket through a bunch of probes that are almost to the sun on a remote, the question of it is am I going to get a different number than what I got before by firing a rocket and leaving the rockets on, which really doesn't matter to a certain point. It's how many days it takes to get to the sun, and what it is The GPS on it hits the last probe. The last probe will turn in the direction of the sun. You'll see a little tiny, it's like kind of looks like not a gun, but a soldering iron inside a metal bracket, and that'll continuously bounce a frequency back and forth, keeping itself lined up every so often. So when that frequency no longer hits that last probe, it tells me that the point of impact, that it actually has hit the sun and whatnot. So the last impact generated a report of, they claim, over 1,000 years and whatnot. They wanted me to take a look at the numbers, do the mathematics, and to see where it actually is at right now. The question of it is if the probes are still there, if they're still lined up correctly, or if they need to be relined up before the missile is shot off. It's nice to think that you can keep a satellite on top of a missile and keep it directed at another satellite, but the problem of it is by the time it hits the satellite referenced on Earth to the position of the missile, sometimes doing a correction can throw that off, and then you just wasted a missile for no reason. The question of it is how big of a missile do I need to use? I don't need to use a continental missile. I don't need to use a mid-grade missile. It's in between a small and medium missile. Enough of a missile to generate somewhere around 1,000 to 4,000 miles per hour. But at the same time, the ability to control it remotely and enough fuel in there to generate enough power to get me from Earth, as in reference, to the sun, as in reference. If I don't make it and I hit another planet, then I gotta fire another one off. As far as Nearin automatically fired 2 missiles off just to cool down what they call the atmosphere. One blew up in the trajectory of 1,000 miles off the sun, and a secondary missile hit the sun, which normally is cooling the outer atmosphere of the sun by pretty much about 10 degrees, maybe 5 degrees, but enough to keep the what you see when you look at the sun off the Earth. These are all mid-class missiles. They're all 3 to 4 story missiles, and the width of them is probably about 2 to 3 burner barrels wide, so filled with nitrogen propellant. It is actually a powder form that is used, and when it gets to the point where it needs to explode, it infuses a large amount of other chemicals which aren't good to breathe, and it explodes vigorously. The secondary missile was technically about 24 to 48 hours in behind that one to give it a chance to explode, need to do what it needs to do with inside what they call the gravitational force of the sun. But it's also actually 500 miles away from the sun on a different trajectory course. So when I fired the first one off from a secondary Mars planet, and then I fired both off from Mars, but both hit accordingly. So I didn't run into the high-end thick nitrogen count of what I expected. This actually causes not an ozone, but it definitely causes a blocker of sorts. If I would have hit both missiles into the sun, I pretty much would have just pissed a lot of people off by causing a lot of white sun glare, which is when you lay down and you lay in the sun and you feel that penetrating like little pins and needles, but not really pins and needles, but it just feels like it hurts, then you know you did something, you screwed up. That's pretty much it. As far as how long you have, you got anywhere between 300 to 500 years, as some may say, but you're going to have a lot of disruption. The closer that Earth breaks away from its own rotation into a closer rotation of the last planet, and I know it's not Neptune, but it's the one I can't hardly remember. It's going to end up taking over another solar rotation of another planet, which recently was destroyed in 2014 when it slammed into the sun, which had been working its way since 1980 closer to the sun. So that's about it. Thanks.